everyone. For today's video, I will explain more about the law of sines and in solving oblique triangles by the use of the law of sines given two sides and an angle, there will be an ambiguous case that might happen. So in these three cases that may occur, no such triangle exists, one such triangle exists, or two distinct triangles satisfy the conditions. So in the previous video, we have already explained some three possible cases that may occur. Therefore, I will be discussing three more examples of the ambiguous case. So let us now proceed with the next example. So in this illustration, we are given angle A, which is an obtuse angle, and it actually measures 110 degrees, together with its opposite side A, which is 15 units, and side B measures 6 units. Now, since this is an obtuse angle having the opposite side which measures 15 units, and comparing that to side B which measures 6 units, we can actually see that by comparison, 15 is greater than 6, and since that is A and B, we could actually say that since A is greater than B, one triangle has formed. Thus, there is one solution for this. So, this is a situation where angle A is an obtuse angle, and in the previous video, we have already talked about the relationship of an angle to its opposite side. So, the larger the value of the angle, the longer the length of its opposite side. So in this case, it actually satisfies that condition. Therefore, one triangle will be created from this. Thus, there is one solution for this triangle. For the next example, we have here an illustration such that A is an acute angle and the side opposite of angle A, which measures 46 degrees, is side A. That also measures 8 units. And a side B, which measures 7 units. In this example, if we are going to compare side A and side B, then we will notice that 8 is greater than 7. So A in here is greater than B. Since the case is A is greater than or equal to B, one triangle has formed. Thus, there is one solution for this. Now, in this situation, we don't have to actually solve for the value of the altitude or the height of this triangle. If you can see right away that A is greater than or equal to B, then that will already give you an idea that there exists one solution for this. Okay, for the last condition of the ambiguous case, we have here an illustration where A is acute, which measures 50 degrees, and side A, which is opposite of that angle, measures 7.5, and side B measures 8 units. So A is 7.5 and B measures 8 units. And as you can possibly observe, side A here has been drawn twice, wherein they were created in a manner that they are placed in two different positions. So, considering angle A, side A, which is opposite of that angle, can be placed nearer angle A, or you can draw it further angle A. So this is a situation wherein if we are to draw an altitude for this triangle, which is labeled as h, which refers to the height of this triangle, and with that situation, we were able to create a right triangle in here with that altitude. Therefore, if we are to consider that right triangle, then we can actually relate that with the acronym SAW, since we are actually discussing about law of sines. So taking the given angle, which is 50 degrees, that is sine 50 degrees is actually equal to the opposite side. So opposite of 50 degrees in here. So from this right triangle, the opposite of 50 degrees is h. So that is h over the hypotenuse, which is actually b. Now, if we are to solve for the value of h by this trigonometric ratio, we can actually transfer b by multiplying b on both sides. So this will cancel out and h now will be equal to b times sine 50 degrees. But since we also know the value of b, which measures 8 units, we can actually substitute that in the equation. So this will become 8 times sine 50 degrees is equal to h. And with the use of a calculator, 8 times sine 50 degrees is equal to 6.128355, and rounding that off to the nearest hundreds will give you 6.13. So h here will approximately equal to 6.13. By taking the value of a, which is 7.5, 6.13 is actually less than 7.5, but we can also compare b here and the value of b, which is 8. So 7.5 is actually less than 8. Therefore, since 7.5 is the value of a, 6.13 is the value of h, and 8 is the value of b, we can actually say that since a is greater than h but less than b, then two triangles has formed. Thus, there is two solutions for this. Okay, so that is the reason why we can actually place the opposite side A in here, wherein we could place it nearer angle A, or we could place it further so that we could create a triangle. So that's the ambiguous case for the given two sides and an angle, such that we have here the comparisons of the height and the two given sides. Okay, so those are the examples of the ambiguous case for an oblique triangle, given that we have two sides and an angle. So by using the law of sines, you might encounter 6 different scenarios in here. Thank you so much for watching, and see you on the next videos.